Hello everyone and welcome back to my channel IB Mathlogy. This is the part 2 of my video. In part 1 I have explained in detail what are complex numbers, and in this part of the video I will be solving some previous year complex number question. So let's start with this question. So we have two complex numbers W and Z given to me, and the equations are given to me like this. Now we have to find W and Z in the form A plus BI. So from the first equation I can write W as 2ZI, and I can substitute this into Z star minus 3W as 5 plus 5I. Now in this W I can substitute, so Z star minus 3 into 2ZI, that will be equals to 5 plus 5I. Now whenever we have Z in the question, we can always write Z as A plus BI, that is the standard Cartesian form, and its Z star, that is the complex conjugate, will automatically be A minus BI. So I will be substituting these two values, so I can write A minus BI minus 6 times A plus BI multiplied by I is equals to 5 plus 5I. Now in the left side I will simplify and separate real and imaginary parts. So I can write it as minus 6AI minus 6BI square, that is 5 plus 5I. And you all know that I square value is minus 1. So I can separate and write it as A plus 6B. I can take I common, minus B minus 6, that will be equals to 5 plus 5I. Now on comparing real and imaginary parts, we can obtain A plus 6B will be equals to 5, and minus B minus 6 will also be equals to 5. Now you can solve this using simultaneous equation. So when you will be solving, you will be getting A as minus 1 and B value as 1. It means my Z is A plus I, and I can also say that my W, that is nothing but 2ZI, will be minus 2 minus 2I. So this is how I will be calculating. This question was worth 7 marks. So all these steps are very much necessary. Now let's move to the next question. Now in this question we have Z to the power 4 as 16I, and the equation has 4 roots. Where Zi is given to me, we have to find these 4 roots. So we are basically finding the nth root, first 4 roots. So we will be using the formula, which is Z is equals to R to the power 1 by N cos theta plus 2k pi by N plus I sin theta plus 2k pi by N, to calculate all the 4 roots of this equation. Now Z to the power 4 is given to me as 16I. It means I can write this as 16 0 plus I. So this will give me modulus Z, and from this I can write as tan inverse 1 by 0, which will give me pi by 2 as my argument. So I have modulus and I have argument. So I can say that my first root will be 2 bracket, I can say that cos, or before going to directly find out the roots, we can further simplify and solve it like Z will be equals to 16I to the power 1 by 4. From here to here I can write it like this, which is nothing but 16 to the power 1 by 4 I to the power 1 by 4. And if I write it in polar form, so I will get as 2 cis, my theta is pi by 2 to the power 1 by 4. But I have 4 roots, so I have to write this in the general form. So I can write as 2 cis pi by 2 plus 2k pi to the power 1 by 4. Now we can apply de Moivre's theorem and we can write z as 2 cis 1 by 4 multiply by pi by 2 plus 2k pi. Now we can put k as 0, 1, 2 and 3. This will give me z1, z2, z3 and z4. So from this I can find out all the roots. So my z1 will be, I will replace k as 0. So it will be 2 cis pi by 8. You can write it in cos and sine form also. And in paper you should write it in cos and sine form. Now this was for k is equals to 0. Now if I put k as 1, so this will be 2 cis 1 by 4 into pi by 2 plus 2 pi, which will give me 2 cis 5 pi by 8. Similarly, if I write k as 2, so third root will be 2 cis 1 by 4 pi by 2 plus 4 pi, which is nothing but 2 cis 9 pi by 8, and at last if I replace z as 3, I will get my fourth root, which is 2 cis 1 by 4 pi by 2 plus 6 pi, which will give me 2 cis 13 pi by 8. So this is how I can find my z1, z2, z3 and z4, all the 4 roots. Now let's move to the next part of this question. Now in this question the roots form a geometric sequence and we have to find the common ratio and express the answer in the Cartesian form. As you all know that common ratio will be z2 by z1 and my z2 was 2 cis pi by 8 and z1 was 2 cis this. Now this 2 will get cancelled. So whenever we have cis any angle divided by cis any other angle, so we can subtract the angle and write this. So I will be using this over here. So this will give me 5 pi by 8 minus pi by 8, which is nothing but cis pi by 2. But the question was to give the answer in Cartesian form. So the Cartesian form will be cos pi by 2 plus I sin pi by 2. Now cos pi by 2 is 0, sin pi by 2 is 1. So this is my Cartesian form, or I can write my answer as I. Now let's move to the next part of this question. Now the roots are represented by the points A, B, C, D on Argand diagram. We have to plot the points. So before plotting the points, let me write the arguments. So the first argument was pi by 8, second one was 5 pi by 8, third one was 9 pi by 8 and the fourth one was 13 pi by 8. We found this from A part. So we have to plot our z1, z2, z3, z4 according to these angles. Now if you see, they all are separated by angle pi by 2. You can subtract theta 2 minus theta 1 or theta 3 minus theta 2. So this or theta 3 minus theta 2 or theta 4 minus theta 3, they all will give you pi by 2 angle. It means we can draw them with a gap of pi by 2, that is 90 degree. So I will be first drawing the axis where you have to mention that this is real and this is imaginary. So first one was pi by 8, means it will lie in the first quadrant. So I can mark it as A. Now next one is separated by pi by 2. So I can draw it like this, and this is my pi by 2 difference, that is my Z2, which is represented by B. And the next one C, that is Z3, that will also be separated by pi by 2. And the last one is also separated by pi by 2, which is my point D. So this is how we can draw it. Next part. Now we have an equation v to the power 4 as a plus bi, and they have the roots as the conjugates of the ones which we got. So from first part it was given to me that z1, z2, z3, z4. If I multiply all those, I will get 16 as my answer. So what I can do is I can find out the complex conjugate. So I can do this on both sides. So this will turn out to be minus 16i because we are taking complex conjugate. And this I can write as 0 minus 16i. It is in the form a plus bi. So from here I can say that a is 0 and b is minus 16. So by solving this, you can get 3 marks in your question. Now next part. Now we have midpoints of AB as A dash, BC as B dash, CD as C dash, and DA as D dash. We have an equation W to the power P equals 2 to the power Q, and the 4 roots are represented by the midpoints. We have to find the least value of P and Q. Now to solve this, first of all I will write the arguments. So arguments of my z to the power 4 were pi by 8, 5 pi by 8, 9 pi by 8 and 13 pi by 8. This we got from the first part, A part. Now they are saying that it is the, for example, A is the midpoint of AB. So we can find midpoint as ZA plus ZB by 2, which on solving will be pi by 8 plus 5 pi by 8 whole divided by 2, which after solving you will be getting 3 pi by 8. Similarly, if we talk about the new radius, so my new radius will be 2 cos of the, you can say, the angle difference whole divided by again 2. This I have also done in the last part. So I got my angle difference as pi by 2 whole divided by 2, which is 2 cos pi by 4. Pi by 4 on solving we will get root 2. So I got my midpoint. So my new midpoint A dash will be root 2 cis 3 pi by 8. Similarly, you can get for B dash, C dash and D dash. So B dash midpoint will be root 2 cis 7 pi by 8. C dash will be root 2 cis 11 pi by 8. And finally D dash will be 2 cis 15 pi by 8. This you can solve, and if you have any doubt you can put in the comment box. I will solve it in my next video. So now the very important is the point, midpoint of a regular polygon will always lies on a smaller circle and same center, and it is rotated by half step. So the number of points, I can write that the number of points are 4 here, which means this is nothing but this is my p value. And if you look at the radius, so radius is root 2, that is 2 to the power 1 by 4, which will give me my q value. But they match every 4th root of the 16th root system because the question says 4 of the roots. So we have to multiply this by 4. So we will get p as 16, our answer, and my q value will be p by 2, which on solving will give me q as 8. Now let's move to the next question. Now we have pz as this, where z is a complex number, so m is positive real, and it is given that z minus 3i is a factor. We have to find the roots. Now to find the roots, first of all, from this I can say that z plus 3i is also factor because it is a complex conjugate. So I got my two roots, and since this equation is a cubic equation, so I have to find the third root. Means I can say that p of 3i is 0 and p of minus 3i is 0. So how I got this? If I equate this as 0, I will get z as 3i, and similarly if I equate this as 0, I will get this. So that's how I have replaced these values. Now if I put 3i into the equation, given equation, so 3i will be 4m minus 3mi plus 36 by m. My z is 3i whole square minus 3i whole cube, which will give me I square is minus 1. So this will be minus 36 by m into 9. I cube will be minus I. So this I can write it as 27i, and this entire is equals to 0. I will write here also 0. Now if I attempt to separate real and imaginary, so I will get this as my real part, plus I can take I common. 27 minus 3im is equals to 0. Now I can equate both of them with 0 because it is 0 plus 0i. So when I will equate it, so if I equate this, my m will be 9. And since it is a cubic equation, so the sum of the roots will be minus 36 by m. So I can write it, I can substitute m value. So I got my sum of the roots as minus 4. Sorry, my mistake, it should be plus 4. So I got my third root as plus 4. It means I can write pz as z minus 3i, z plus 3i, and 4 minus z. So this will be my complete solution. And that's all for this video. If this video helped you, please give a thumbs up. It really helps the channel grow and reach more IB students like you. Subscribe to IB Mathlogy if you haven't already. Drop a comment below. Tell me which part of the complex number you want to study or I should explain. Good luck with your exams. See you in the next one.